Hi everyone, good day. Welcome back to our next video on C character set and tokens. We all know that the 26 letters of the English alphabet is the basic for constructing the English language. Same way, the C programming language also has its own character set. A character set defines the valid characters that can be used in a source program. Characters used to write C programs are classified under two types: source character set and execution character set. Let us first discuss about the source character set. It is used to construct the statements in the source program. The source character set are of four types: alphabets, digits, white space characters, and special characters. In alphabets, we have capital A to Z and small a to Z. In digits, it includes 0 to 9. In white space character, it includes blank space character, horizontal top space character, carriage return, new line character, form feed character. In special characters, it includes many special characters like comma, period, colon, semicolon, exclamation, person symbol, asterisk, right parenthesis, left parenthesis, right bracket, left bracket, greater than, less than, slash, backslash, and so on. Next is the execution character set. It is employed at the time of execution. It is also called as non-graphic character as it cannot be printed or displayed directly. Only the effects are visualized in the output. It is represented by a backslash followed by a character. They are generally called as escape sequences. Few escape sequences are backslash followed by a single quote. It prints a single quote. Backslash followed by double quote. It prints double quote. Backslash followed by backslash. It prints backslash. Backslash followed by 0. It is the null character. It prints nothing. Backslash followed by A. It gives a beep sound. Backslash followed by B. It is the backspace. It moves to the previous position. Backslash followed by F. It is the form feed. It moves to the initial position of next page. Backslash followed by N. New line. It moves to the next line. Backslash followed by R. Carriage return. It moves to the beginning of the current line. Backslash followed by T. Horizontal tab. It moves to the next horizontal tab. Backslash followed by V. Vertical tab. It moves to the next vertical tab. So both the source character set and the execution character set together constructs the statements of the source program. The first basic building block of the C program is the C character set. The next building block of the C program is the token. C tokens are the smallest individual units that constructs the C programs. C programs are written using these tokens and syntax of the language. C tokens includes keywords, identifiers, constants, strings, special symbols, and operators. Let us discuss about them one by one. Keywords. There are 32 keywords available in C. Keyword is a reserved word that has a fixed predefined meaning in the programming language and cannot be changed. All keywords must be written in lowercase, as you can see here. A keyword cannot be used as an identifier name in C language. Few frequently used keywords are integer, else, if, for, while, and so on. So these keywords are used in constructing the statements in the C programming language. We cannot use these keywords as identifier names. The next token is the identifier. An identifier refers to a variable name, label name, function name, a typedef name, a macro name, a member of a structure, a union, or an enumeration. So any name that is given by the user can be referred as an identifier. So here we have few sample identifiers, valid identifiers as well as invalid identifiers. So when we say valid as well as invalid, then definitely there should be some rules that needs to be followed when we are writing an identifier name. So the rules are: an identifier must always consist of only letters, digits, or underscore. So we cannot have any other special characters except underscore. So any other special character, say for example like blank space or comma, so it cannot be used when we are writing an identifier. The first character must always be a letter. It cannot be a digit. So the first character can be an uppercase letter, or it can be a lowercase letter, or it can be an underscore. We cannot use keywords when we are writing a valid identifier name. So if you see here, so these are the rules that has to be followed. If you see the valid identifiers, you can see the first example. It starts with a uppercase letter and we are having underscore between student and name. If we give blank space, then it becomes an invalid identifier. So in the second example, we are using both alphabets as well as number, letters as well as number. In the third example, it starts with an underscore, which is valid. Only underscore is allowed when we are writing an identifier name. So if you see the invalid identifiers, you can see between student and name, we have a space. So that is why it becomes an invalid identifier. So the next example, it is invalid identifier because it starts with a digit. So it is invalid. The third example, it is a keyword if. So keywords cannot be used as a valid identifiers. The fourth example, we are using a dollar sign, which is a special character which is not allowed when we are writing an identifier name. The next token is the constants. Constants is an entity whose value remains the same throughout the execution of a program. Constants in a statement can be placed only on the right side of the assignment operator. It is classified as literal constant, qualified constant, and symbolic constant. Let us discuss about them one by one. Literal constant denotes a fixed value. Literal constant includes integer literal constant, floating point literal constant, character literal constant, and string literal constant. What is integer literal constant? It refers to a sequence of digits. That is, it is integer. There are three types of integers: decimal integer, octal integer, and hexadecimal integer. Decimal integer, it consists of a set of digits that is from 0 to 9 preceded by an optional minus or plus sign. So we cannot include embedded space, comma and non-digit characters between these digits. Few examples for decimal integer: 298 minus 240 plus 98. So you can see there is no space in between these digits. We have only integers from 0 to 9. The numbers can be either preceded with a negative sign or it can be preceded with a positive sign. Then we have the octal integer. It consists of any combination of digits from the set 0 to 7 with a leading 0. So that is the difference. Here the number will be preceded by a 0. You can see the example 017, 0162. Next is the hexadecimal integer. It is a sequence of digits preceded by 0, small x or capital X. So you can use either small x or capital X. That is considered to be hexadecimal integer. It consists of a combination of digits from 0 to 9 and also include letters from A to F or small case letters from A to F. These letters capital A to F or small a to F represent the numbers 10 to 15, which means A represents 10, B represents 11 and so on. F represents 15. So few examples, valid examples: 0 capital X to 4, 0 small x to 8, 0 capital X AF. So AF can also be written in small case. So there are some rules for defining this integer literal constant. So all the three integer literal constants, decimal, octal and hexadecimal, it must have at least one digit. The decimal point is not allowed in integer literal constant. The number can be either a negative number or it can be a positive number. No special characters or blank spaces are allowed. So if it is a negative number, the sign must be preceded. We have to give a negative sign. For positive number, the sign is not necessary. Even if we specify, it is not wrong, but it is not necessary. Next is the floating point literal constant, otherwise called as the real constant. Integer numbers, they are inadequate to represent quantities that vary continuously, such as temperature, heights, etc. These quantities are represented by numbers containing fractional parts, like, say for example, 23.1 minus 12.8. Such numbers we call as real or floating point literal constants. A real number can also be expressed in exponential notation, like a number 215.65 can be represented as 2.1565 E2. So E2 means multiplying by 10 to the power 2. Therefore, this floating point literal constants can be written in a fractional form or it can be written in an exponential form. So the rules that has to be followed for writing floating point literals in fractional form: it must have at least one digit. It should have a decimal point. It can be positive or negative. No special characters or blank spaces are allowed. By default, it is of the type double. The size of the floating point literal constant can be modified by using the length modifier small f or capital F. So a valid example for fractional form: 29.8 minus 98.3. So the rules for writing floating point literal constant in exponential form: the exponential form has two parts, mantissa and the exponent part. Both are separated by either capital E or small e. Mantissa is either a real number expressed in decimal notation or an integer. Mantissa can be positive, negative. By default, it is positive. Mantissa should have at least one digit. And the next, the exponent, it is an integer number. There should be no decimal point. Again, it can be positive or negative. No special characters or blank spaces are allowed. So valid examples for exponential form: 2 capital E 10, 2 capital E minus 12, minus 2.5 capital E 11. So here after the E, that is the first example we have given it as E10, it means that 2 into 10 to the power 10. This is the character literal constant. It contains a single character enclosed within a pair of single quote marks. Character literal constants are classified as printable character literal constants and non-printable character literal constants. In printable character literal constant, we have all the characters like alphabets, digits, special characters. So they need to be enclosed within a single quote. In non-printable character, we have escape sequences. All the escape sequences comes under non-printable character literal constants. Next is the string literal constant. It is a sequence of characters enclosed in double quotes. The characters may be letters, numbers, special characters and blank space. As you can see in the example, the first example we have hello followed by exclamation mark, a special character. So it is enclosed within double quotes. So that is very, very important. If it is a string literal constant, it has to be enclosed within a double quote. Whereas a character literal constant will be enclosed within a single quote. Even if it is a single character, if it is enclosed within double quote, then it is a string literal constant. Say for example, you can see the third example. We have only a single letter X, but you can see it is enclosed within a double quote, which means that it is a string literal constant. Suppose if it is a enclosed within single quote, then it becomes a character literal constant, which is not same. String constant does not have any equivalent integer value, which is the ASCII value, whereas a character constant, it has an equivalent integer value, that is ASCII value. String literal constant, they are normally terminated by a null character. Till now, we have discussed about the literal constants: integer literal constant, floating point literal constant, character literal constant and string literal constant. So now let us discuss about the qualified constants. It is created by using the const qualifier, CONST qualifier. So as you can see in the example, the examples are prefixed by the qualifier CONST. So which means that the value of the character variable that is following cannot be changed. So here in the first example, the variable a, if it is prefixed by the const qualifier, the value of the a cannot be changed. Similarly, the second example, the value of the integer variable a cannot be changed. So once it is initialized to 10, the value cannot be changed later in the program. So this is called as the qualified constants. Next is the symbolic constants. It is created with the help of the define preprocessor directive. So in the example you can see we have hash define pi 3.14. Here pi is a symbolic constant. It is defined as a symbolic constant with the value 3.14. So wherever we are using pi in the program, which is a symbolic constant, it will be replaced by its actual value, that is by 3.14 during the pre-processing stage itself. So this type of definition is called as the symbolic constant. In this video, we have discussed about few fundamental concepts in C, which is the basic building blocks of the C programming language. It will be continued in our next video where we will be discussing about operators, operator precedence and associativity. Hope this video was useful to you. If this video was useful to you, please don't forget to subscribe, like and share. We will meet in the next video. Thank you.